Today, I'm going to show you how to do your assignment number 1 of Module 22. First, let's create a project folder. So follow the instructions. We're going to start from the first one. So first, I'm going to create a folder. I'm going to create a folder in my OneDrive. Okay, Module 22. All right. So I'm going to create a folder which is Module 22. I'm going to follow strictly the instructions in the assignment. Then I'm going to create a subfolder, projects, and then open AutoCAD, Autodesk Inventor, and go to the Tools, Application Options. So for the file, I'm going to set up project as my project folder. So I'm going to click here, go to File, Project folder. I'm going to click Select. I'm going to choose my Module 22 folder. This is Module 21, Module 22. Under here, Module 22, not this one. So I'm going to Module 22. I have a folder which is called Projects, right? Hold on. Let me check. Yeah, Module 22 projects. So yeah, Module 22 and then projects. I can select this as my project folder, and then I'm gonna click apply and click close. All right. Next, I'm gonna create a project folder, assignment number 1. Click new, projects, new. So I'm gonna new single project. Click next. I'm gonna name this assignment 1 and click finish and click OK. Now my assignment 1 is the current project name. All right, I click done. Next, I'm going to select the template. So this is a metric part. So I'm going to start from the metric template, standard IPT, and create a new part. I'm going to first create the different components, and then we're going to assemble them together. So the first component I'm going to create is this cylindrical pipe. All right, so I'm going to start sketch. So for this pipe, I'm going to use the sketch command. Use the revolve command. So the total length is 260. So I'm going to sketch on XY plane. The first step after create new file is to project geometry. Click the construction line and select the project geometry, and I'm gonna project for this one gonna be X and Y. Okay, so you can see from the chart here. So I'm gonna project X and Y. So you have two reference line and check this. And next I'm gonna draw the contour. So this is symmetric part. So I'm gonna just draw half of it and then mirror. All right. So I'm gonna draw this shape like here, and yeah, so gonna be larger diameter like this, and like this. Make sure when you draw it, make sure your line is either horizontal or vertical. Then I'm gonna add the I'm gonna mirror this about the vertical axis. So I'm gonna mirror and select old feature, and then select the mirror line, gonna be a vertical line, apply, click that. All right, and then I'm gonna give dimensions. So for the overall length is 260. All right, this is 260, and for each end is 22. So this dimension is 22. And for the diameter, so if you want to give diameter, so you can change this reference line, select this line, make it a center line. All right. Then you can give the diameter dimension. All right. So for this diameter, this is 76. This is 76. Okay, so it's a little bit weird, so it's better to give the small dimension first. So the small diameter is 48. So let's give this first, 48, and then give this 61 from here to here, 61, and this one is 76. All right. If you do the other way, give the big one first, you need to drag your drawing to adjust. All right, so I already have this dimension, just change this to 76. All right, now I have the fully constraint in the corner. You see here, fully constraint sketch. Next, I'm going to use the revolve command to create the pipe. All right, finish sketch. I want to save my part first. So this is you can make this you can give this name as pipe. All right, click save, and they're gonna revolve. And for the axis, it's automatically selected because you already draw this center line. This is your vertical horizontal reference line. All right. So this is fine. I want this to be 360 degrees, and click OK. So this is my first part. For the material, I can give the material. Let me see. The material is ASTM. Sorry, this is hold on. Let me see the material. It's ASTM sharp support. It's SAE 1030 hot rolled steel. All right. Let's check the steel. Do we have hot rolled steel? Simply don't have this. All right. In this case, from the knowledge we learned in module 9, so 1030 is carbon steel, so we can just select as carbon steel and use the default appearance and save. So this is your first part. For your second part, the second part, for the second part, I'm gonna create the base plate, which is 50 times 220. All right. This is a very simple one. So I create new file. Same thing, metric mm ipt. I'm gonna start my drawing from this plane. I just want to use the for this one I don't need reference because I want to use the origin as the reference. So I'm gonna draw. This is 50 by 220, 220 by 50. All right, so this is my sketch, and then I'm gonna click finish, save my file. This is the base, B-A-S-E, base, and let's name this base 1 because we have another base plate. All right, this is base 1. Click save and use extrude. So the thickness of this, from the front view, we know this is 10 millimeter. The default is 10. So normally it's better to prefer symmetric because when you add your constraint, you can have the center plane in the middle of your geometry. All right, so better use symmetric option and click OK. So the same thing. So the material we're going to apply, this is 1067 DC hot rolled plate. So it's also carbon steel. So we're going to use the same plate, carbon steel. We don't have all the materials in the list. So we will just manually change that in the parts list. All right. but we know this is carbon steel, so the density will be fine. So we save this. For the next part, we're going to create the large base plate. Create. Actually, it's not finished yet. So for this base plate, we have holes, right? If you go to the top view, you have two holes, which is finite 62-degree countersink 3 deep, right? You have two holes, one here, right? So we're gonna create holes. So this is an countersink hole. So this is 62 degrees, 62 degrees, and this is 5.9. So this is 9 millimeter and 3 deep. So the depth is 3. Actually, we don't have control of this. So what should we do? 5.9 and 62-degree countersink 3 deep. So we're gonna create a quick drawing. Okay. Quick drawing metric. Okay, we can just do it here. So we can have a quick sketch. I'm gonna find out how much is that. So I'm gonna just draw. Let's just draw a hole, which is so we have this. Let's create a geometry here. Project the x-axis. So we have this. Let's make this center line. So I'm gonna mirror this. Mirror about center line. Apply that. Okay. So this diameter is 9. All right. And this angle is 62. Right. 62. And the depth from here to here is 3, right? Then we can find out what is the size for this one, all right? From this to this is accept. This is 12.605, all right? So this is the dimension we need for the hole, right? 12.605. All right, so we're gonna finish sketch. I don't need this sketch. This is just for finding out the dimension we need. So we go to hole command. This is countersink. So this is 12.605. Yeah. So this is 9 millimeters. This is 62 inches, 62 degrees, all right, 62 degrees. And this is the through hole, And if you see reason red minus sign here, it doesn't allow you to allow the center point creation. So it means if you put the cursor here, it says allow center point creation is off. Then you click here, you can add hole in the parts. All right, so I'm gonna put it here. For this dimension is half of this, so you're gonna in the middle. So gonna be 50 divided by 2 gonna be 25, and for this one gonna be 220 minus. Actually, you have dimension there. It's 15. All right, 15. All right, so this is the first hole, and you click OK, and you can use your mirror command to create the second hole. Go to mirror, and you're gonna select your hole, and the mirror plane gonna be this plane, right? YZ plane. You see the preview here. So click OK. Now you have the holes. All right. So this finishes this base one. Let's get started with the second base 2. Base 2. Okay, so base 2, we're gonna create a new file. Standard mm create standard mm.apt. So we're gonna also sketch on this plane. This is 160 by, what is the overall dimension? It's gonna be 150 times 2 plus 300. So I'm gonna also use this 2-point center rectangle. Gonna be 160 by 300, right? So this is my sketch for the constraint because I picked the origin as the center of this sketch. Click Finish Sketch. I'm gonna save my file. This is base 2, and click Save. I extrude. So the thickness is also 10 millimeters. So click. You can also use symmetric if you like. Click OK. All right. Save. Apply. Same material. Carbon steel, and save. All right. For this one, you also have for D. All right. You don't have the hose. Actually, for D is plug weld. So for this part, we don't draw anything for now. All right. So we're gonna just leave it there, and then we're gonna um, continue with the next component. We're gonna draw the support, which the support of the triangular support of the pipe. So we're gonna create a new part. So create. So this is a triangular support. I'm gonna sketch on this plane. This plane. Okay, so if you use this as the origin, so you don't need to project geometry because we're gonna just draw on this portion. But for your reference, it's better to draw that to easier pick the vertical horizontal direction. Right, so I'm gonna project geometry. In this case, it's gonna be x and y axis, x and y, and then I'm gonna just draw. Make sure you uncheck this. Gonna draw a triangle, and I'm gonna give a dimension later. So the dimension of this are gonna be oh, so this is this is a whole part. Sorry, so this is not half of this. So I'm gonna change this, delete this. I'm gonna mirror these two lines. I'm gonna mirror this and this about this line. Apply. Click that. Then I gave a dimension. So from here, I have a circle which is 76, right? 76. So the center of this circle gonna be from here, center to this line is 100. This is from front view, all right? So 176. Yeah, so it means my drawing is small, right? So for this one, the dimension is 300 minus 50 is going to be 250 because from the top view, we can find that this line from this point to be 250, right? And the angle, okay, we don't know the angle, but we know that actually we shouldn't draw these two lines. Let's just delete this. This line is from this quadrant to here. All right. Okay. And I can mirror this about this. apply. Okay, so here this one and this one, so this should be horizontally aligned. All right, then I'm gonna trim this portion that I don't need. Trim this portion. So this is the shape of my my sketch. All right, so then I click finish. I save this file. This is support. All right, and then I extrude. Use symmetric. So the thickness for this one is also 10 millimeters. Okay, so I'm gonna click OK, and then I'm gonna apply materials, carbon steel, and click save. Next part is the 45-degree support. All right, so for this one, we don't have dimension in the top view, so we have 45 degrees. We have, let me see, this is much is that? Okay, let me see. So the dimension of this is 45 degrees, and the height, I have some problem with my drawing here. Okay, let me check this Word document. Number 1. I'm gonna draw now the things missing is this portion, and this portion. So for this one, we have dimension here. So from the top we know, so we need to do some simple calculations here. So the distance from here is 30 plus 10 is 40. From this to this end is 40, right? So, but this is longer than that. Hold on. This is 10. Okay, this is good. 10, 45 degrees, and the height is, okay, let me find that height. So gonna be, okay, so this distance from here to here, the height is 100 minus 10 minus 10 is 80. 80 from here to here is 80. 80 minus half of 76. 80 minus 36, 38 is 42. So the height of this is 42. All right. So I'm going to make a sketch. 42. Okay, so let's create new part. So we're going to give it yeah, the same thing, put ipt. I'm gonna sketch on this plane in this case. So I'm gonna just draw a rectangle. Do we need an, yeah, I think we better project geometry. Project, so in this case gonna be Z and Y. So Z and Y, all right? Z and Y, yes, Y, okay. So we're gonna sketch and check here. So your sketch gonna be from here to here and to here to here and from here to here, right? So we have this. So this from here to here, we have 42, right? 80 minus 38, 42. And this is 40 degrees, 45 degrees from here to here, 45 degrees. And this is 10 millimeters from the dimension from here to here is 10. All right, so this is for the constraint. Let's just finish sketch and save this. as this is support 1. All right, support 1. Okay, I'm gonna extrude, so I'm gonna use symmetric, and yeah, so apply the material carbon steel. Okay. All right, so this is the first one. The second one, actually, you can just save this as support 2 and modify the sketch. So you, in that case, you don't need to apply the material again. All right, so I'm gonna do this way. I'm gonna just save as. So I'm gonna make this support 2. All right, support 2. Click save, and I'm gonna just edit my sketch here. Edit sketch. So my sketch, I'm gonna just this is 42, or it doesn't change. So I'm gonna delete this. All right. I'm gonna delete the point as well. I don't need anything from previous sketch. So this sketch, this is for the middle part. For the middle part, let's do some calculation here. So it's gonna be 160, which is this dimension, 160 minus 20, 10 here, 10 here, 140, minus 10 here, 10 here, 120. So it's going to be 120, all right? 120 times 42, all right? So this is 120 from here to here, 120. From here to here is 42, all right? So it's going to be 42 by 120, all right? So this is my support. See, you change the sketch, but it has problem with the update. You click accept, and you're gonna right click, edit feature, you're gonna reselect the contour, all right? And then click OK. Now you see the carbon steel has been applied and the part has been updated, right? We're gonna go back to support number 1. Actually, let's open support number 1. Open support 1. I want this to use this to save as support 3. All right, save as support 3. Okay. After save this, then I'm gonna edit my sketch, edit, and then I could keep this one because I want my sketch to be in other direction, but I keep this line. So I'm doing this one, and this one, right? So for this one, this is 60 degrees, and 60 degree, yeah, let's say it, and this is 10 as well. So from here to here is 10. From here to here is 10, right? 10, and this is 42. From here to here is 42. Okay, so this is my part number 3. Same thing except, and right click, edit feature, and reselect the contour geometry, and click OK. Click OK. Now I have 3 of them. Next, now I have all my components created. Next step is to assemble them into an assembly. All right. I'm gonna start a new assembly. In this case, it's not a standard standard millimeter IM. It's gonna be a weldment because this is the weldment assembly. So I'm gonna select weldment and see mm.am create. I'm gonna put my components. So I'm gonna, so you see, you automatically jump to weld. But let's go back to assemble first. I'm gonna place component. We're gonna use the because the base 2 is the largest part in the base, is in the center. Let's put this to be in the origin, all right? So again, but because base 1 is not in the center, right? So we choose base 2. Click. Your first part is always center to origin, grounded. So you click this one, open, and go to isometric to see if this is okay. All right, if you want this direction is fine, then you don't need to do any rotation. If you want to do this to show in another way, you can rotate about y axis 90 degree. Right click, rotate y 90. So you can put it in this direction if you prefer. Then right click, place grounded at origin. All right, click. Now you have the first part. For the rest, you can add them together. But for the first part, always insert the first part individually. All right, grounded in at origin. For base 1 pipe, you just hold Control key and select all the other part and click open. So you're gonna put everything here. So for this plate, you need a second case. So you just hold Shift and drag this. You have second of this. This one we need one. This we need a second case, second part, second time. So hold, Shift key and drag. Have this second page. So this should be fine now. Next, we're gonna assemble this. First, we're gonna assemble this and this with this. All right. So first, we're gonna just use constraint. I'm gonna make this surface to be in contact with this. All right, and then so I'm gonna use this to be flush with one of my surface here. Gonna be flush with this. So now it's not flush. See, I need to select flush like this. All right, and next one I'm gonna make this to be centered. So I'm gonna select this part, and find the center plane. Actually, this is grounded center, so I don't need the center plane of this. I just need center plane of this part. All right. I'm gonna find the center plane. So this is the center plane of my base 2. I want this plane to be coincident with this plane. You see, this is my xy plane. You see, this is the xy plane. Xy, xz, yz. So let me see which is the plane. This is this one. This is the one. Yeah, gonna be with xy plane. This one to be concentric, not concentric, overlapping, coincident with this plane. Okay, click hold. Hold Control key and select this as well, and add constraint. So I want this to be, let's see, first let's go with this and apply. It doesn't work. Added relationship, make this flash. So you see now it works. Apply. Same thing, we're gonna assemble this surface with this one, and then we're gonna make this surface flash with this surface. It's gonna be, yes, it's flash. Good. Click apply, and then I'm gonna find you can go to isometric view and drag this a little bit to move this here, and so I'm gonna find this in the browser. Find the plane, origin plane. So this plane to be, hold Control key and select this XY plane and select constraint. I'm gonna apply this. It doesn't work. Same thing, flash, click, apply. Okay. So I have this. I think there's something around here. See, one of the constraint is not good. Right? You see the whole. This is not correctly assembled. So I'm gonna go back and edit my sketch here. So this flash should be flash. I can right click, edit, and change this to this. Click OK. It means you have a problem, and now I don't click edit because I know this is okay. So I need to accept this, and I'm gonna edit this flash. All right. You see there is one with problem here. I'm gonna edit this. Right click, edit. I'm gonna change this to mate. Then it's in the correct location. Click OK. All right. So you have these two parts assembled. I don't see the edge, so it's a little bit difficult for me. So I'm gonna click here, check view style, visual style. I'm gonna change this to shaded with edges. Now it's easier to see the feature. All right. Next, I'm gonna assemble the this part. Okay, so for this part, gonna be mate this surface with this surface, right? And click apply. Same thing here is also for this one, gonna mate this with this, all right? And for the other mate, so I click cancel. I'm gonna make this one. So for this one, the center plane is here, right? This plane, YZ plane. You see, I want this YZ plane to be coincident with my, let's see, with in the origin. So what is my origin plane? So gonna be YZ plane in the origin as well. See, I want these two to be overlapping. You see, I click mate, it automatically add the constraint and click apply. Same thing for this one. I'm gonna find this in the browser. This is my cancel. I click here. So this is my second support. I find the YZ plane as well. Click, hold Control key, and you're gonna select this YZ plane and add constraint. It automatically add that constraint. Apply. But you see these two parts overlap with each other. I just drag this to make them part separate. All right. So next constraint is from top view. We know this. We want this surface and this surface to be flush, but with an offset of 10 millimeter. 10. Click OK. Apply. Same thing, this and this flush with an offset of 10. Click here, we have 10 here. Click apply. Okay, now I have this. Next, I'm gonna add this one. So I'm gonna click constraint. Always select the cylindrical surface until you see an axis, right? Click to make this to be made with this surface. You see, you select the cylindrical surface, you see an axis here, right? Click OK. And the distance, so let's see what is the distance here. So we have 22 here from top view. We don't have a dimension here, but it seems that we have this line, this end, and this end flash. All right. So this end and this end flash. All right. So I'm gonna make the back flash. So I'm gonna make this end and this surface flash. All right. Click OK. Now this is the tube. All right, the pipe. Next, I'm gonna add this. So gonna make this surface made with this surface. All right, and make this surface made this surface. All right, and they're gonna find this part in the find the origin plane. Which plane we're gonna use? We're gonna use the YZ plane as well. You see, that's why I always ask you to when you do extrusion, always use symmetric. In that case, if you use symmetric, you're gonna use when you assemble the component, it's much easier to select the symmetric plane, which is the original plane. All right, hold Control key. And we're gonna, oh no, let's find the YZ plane and hold Control key, select this, and make these two plane overlap. Click apply. It doesn't work. Edit sketch. Let's make this flash. Okay. Click apply. Now it's work. So for the 45-degree one, so we're gonna make this one mate with this one. Actually, this is flash. It should be mate. All right. Let's find this one in the browser. Okay, and change this to mate. All right, click OK, and I want this surface to be made with this surface. Okay, and I can use the. I think there's something wrong here. This is 42, 100. And this. I'm gonna double check the dimension later. It seems there's something wrong here. You see, we have a gap here. Let's assemble this first. All right, so this is not fully constrained yet. See, uh, actually you can use the flash for this face, but it's always good to select an origin plane if possible. So I'm gonna select this part and find the YZ plane and make this coincide with the YZ plane origin, right? Click, hold Control key and click constraint, mate, apply, doesn't work, flash, apply. All right, same thing for the other one. So this surface should be made with this surface. Click OK, and again, so I chose flash. Let's find this in the browser. So this should not be flash, should be mate. Edit, change to mate. Okay. And make this surface mate with this surface. All right. And find the YZ plane of this to be mate with this YZ plane. Click mate, flash, apply. Now it's okay. Now let's check why we have a gap here. Let's save this. I should have saved at the very beginning. So this is assignment 1, M22, M22 assignment 1, control guide. Control guide. All right. Click save. Let's find out the problem. Why this is not can contact. Let's make some calculation here. So this is 100 from the top view. Let's do the calculation. So from here to here is 100 minus 20. So from here to here is 80. 80, 80, yeah, it's 80. 80 minus half of 76. So 30, this is 38. 38 plus, yeah, it's 42. Why? It's weird. 100. Let me check this part. All right. Let's go to the component. Check this one. Open. Open. Check the sketch here. The sketch. Okay, so the problem is here. So the 100 is not from the bottom. Okay, is it 100 from the bottom? So if I draw this way, so this distance I have in my sketch going to be 100 minus 20, so going to be 80. From here to here is 80. It's not 100, all right? So in this way, you find the problem of your design, the errors in your design. So it's 80 because I gave 100, so it's wrong. So let's go back to my assembly and just click here to update. See, now it's worked, right? So this finishes the assembly of this control guide, assignment number 1, module 22. I'm gonna give you a demonstration on the 2D drawing in a separate video.